After studying this module, you shall be able to know what is natural fiber and synthetic fiber, the types of fibers, what is the difference between synthetic fiber and the natural fiber, general comparison, microscopic comparison. What is fiber and its role in forensic science? Fibers are materials that have continuously discrete elongated pieces similar to pieces of thread. They can be formed into strands, yarn or cord. Trace evidences such as the fibers is useful in connecting people, places and things with one another, which include determining where the target was better to dismiss, the type of rope used to physically commit the murder, etc. Fibers as a trace evidence can be very helpful in recreating the events of the day. These are significant in cases which involve personal contact, for example, in case of physical attacks or murders. Fibers are divided into two groups, natural fiber and synthetic fiber. The comparison of synthetic and natural fiber. What is natural fiber? Natural fiber, any hair-like raw material directly obtainable from an animal, vegetable or mineral source and convertible into non-woven fabrics such as felt or paper, or after spinning into yarns into a woven cloth. A natural fiber may be further defined as an agglomeration of the cells in which the diameter is negligible in comparison with the length. Although natural abundance in fibrous materials, especially cellulose types such as cotton, wood, grains and straw, only a small number can be used for textile products or other industrial purposes. Apart from economic consideration, the usefulness of a fiber for commercial purposes is determined by such properties as length, strength, pliability, elasticity, abrasion, resistance, absorbency and the various surface properties. Most textile fibers are slender, flexible and relatively strong. They are elastic in that they stretch when put under tension and then partially or completely return to their original length when tension is removed. Next is the natural fiber, which is further classified into three classes: animal hair, vegetable hair and mineral fiber. Animal hairs. Animal hairs are natural fibers that consist largely of a particular proteins. Instances are silk, hair, fur including wool and feathers. The animal hairs used commonly both in the manufacturing world as well as by the hand spinners are wool from domestic sheep and silk. Also, a very popular are alpaca fiber and mohair from Angora goats. Not all animal hairs have the same properties, and even within a species the fibers is not consistent. Merino is a very soft fine wool, while castwool is coarse, and yet both merino and castwool are types of sheep. This comparison can be continued on the microscopic level, comparing the diameter and the structure of the hair. With animal fibers and the natural fibers in general, the individual fibers look different, whereas all synthetic fibers look the same. This provides an easy way to differentiate between natural and synthetic fibers under a microscope. Silk fiber. The fiber formed by the secretion from the glands often located near the mouth of insect during the formation of cocoon. Example, silk fiber is obtained from the cocoons of silkworms. This fiber has double filament, is smooth and glossy. The fabric is lightweighted but can keep its wearer warm. The double fine and glossy filament can be easily seen, which looks like translucent shafts, while silk or tush fiber shows a distinct from than the cultivated silk. It is compressed, rough, dense and broader fiber consisting of fine crippled lines all across the surface, while cultured silk is narrower fiber with no mark on it. Wool fiber. It is acquired from sheep. It consists of scaly, corkscrews-like appearance when seen under the microscope. These fibers can be stretched, doesn't crinkle and comes back to its normal shape. It can also easily absorb water and is soft. This fiber is famous for its capability to breathe, thereby keeping wearers warm in the winter season besides keeping somewhat cool. When rubbed, these fibers easily pick up static electricity. Vegetative fiber or plant fiber. A wide range of plants including cotton, kapok, jute, flax, rame, sisal and hemp may be used to produce plant fiber, and many fiber plants are grown as a field crops to make paper, cloth and rope. Vegetable fibers are generally based on arrangements of cellulose, often with lignin. Cotton. The processed cotton fiber consists of nearly pure cellulose and is produced from the plants of genus Gossypium of the mallow family Malvaceae. The cotton plant produces large, showy, white, creamy or yellow flowers that fall off to a leaf, a large capsule or a cotton ball that contains both the seeds and a mass of white downy cotton fiber. These fibers look as the flat bands when viewed in microscope, which are somewhat wrapped. The fabric produced from cotton fibers are soft, captivates water and creases easily. Cotton fabrics are light and cool. Linen. These fibers obtained from the stems of flax. Plant fibers are jointed, looks like a miniature bamboo. These fibers are glossy, strong, gets softer with the use, grabs water and creases simply. Linen gets softer with the use and is considered a cool fabric for warmer climate. Mineral fiber. Mineral fiber includes the asbestos group. It is found in the sea. For example, asbestos fiber. What is synthetic fiber? Synthetic fiber are also called as man-made fiber. Synthetic fibers are the result of extensive research by scientists to improve on naturally occurring animal and plant fibers. In general, synthetic fibers are created by forcing, usually through extrusions, fiber forming materials through holes like spinters into the air and water, forming the thread. Before synthetic fiber were developed, artificially manufactured fibers were made from polymers obtained from petrochemicals. These fibers are called synthetic fibers and also called artificial fibers. Some of the fibers are made from plant cellulose. They are called as cellulose fibers. These fibers, also known as chemical fibers, are the fibers whose chemical composition, structure and properties are considerably altered in the course of the built-up process. Now next is the synthetic fiber, which is classified into regenerated fiber, semi-synthetic fiber and synthetic fiber. The regenerated fiber. Regenerated fiber is created by dissolving the cellulose area of plant fiber in chemical and making it into fiber again by viscous method. Since it consists of cellulose like cotton and hemp, it is also called regenerated cellulose fiber. Regenerated fibers are manufactured from natural sources including mottle and laucil. Semi-synthetic fiber. Semi-synthetic fibers are made from raw materials having natural long chain polymeric structure and are simply altered and partially degraded by chemical procedures. In distinction to totally synthetic fibers, for instances nylon, that is polyamide, or Dacron, that is polyester, that the chemist creates for low molecular weight compounds by the process of polymerization or chain building reactions. The first semi-synthetic fiber is rayon. Synthetic fibers. Synthetic fibers are made from synthesized polymers or small molecules. The compounds that are used to make these fibers come from raw material such as petroleum based chemicals or petrochemicals. These materials are polymerized into a long linear chemical that bond to adjacent carbon atoms. Different chemical compounds will be used to produce different types of fibers. Synthetic fibers account for about half of all fiber use, with the application in every field of fibers and textile technology. Altogether, many classes of fibers based on synthetic polymers have been evaluated as potentially valuable commercial products. 4 of them are nylon, polyester, acrylic and polyolefin dominate the market. These 4 account for approximately 98% by volume of synthetic fiber production, with polyester alone accounting for around 60%. There are several methods of manufacturing synthetic fiber, but the most common is melt spinning process. It involves heating the fiber until it becomes the melt. Then you must draw out the melt with tweezers as quickly as possible. The next step would be to draw molecules by aligning them in a parallel arrangement. This brings the fibers closer together and allows them to crystallize and orient. Lastly, the heat setting. This utilizes that to penetrate the shape, dimension of the fabrics made from heat sensitive fibers. Metallic fibers. Metallic fibers are manufactured fibers composed of metal, plastic coated metal or metal coated plastic or a core completely covered by metal. Gold and silver have been used since ancient times as yarn for fabric decoration. More recently, aluminum yarns, aluminized plastic yarns and aluminized nylon yarns have replaced the gold and silver. Metallic filaments can be coated with transparent films to minimize tarnishing. Metal fiber may also be shaved from wire, that is steel wool, bundle drawn from larger diameter wire cast from molten metal or grown around a seed, often carbon. Carbon fiber. Alternatively, graphite fiber or CF is a metal consisting of fibers about 5 to 10 micrometer in diameter and composed mostly of carbon atoms. To produce carbon fiber, the carbon atoms are bounded together in crystals that are more or less aligned parallel to the long axis of the fiber, as the crystal alignment gives the fiber high strength to volume ratio, making it stronger for its size. Several thousand carbon fibers are bundled together to form a tool which may be used by itself or woven into a fabric. The properties of carbon fibers such as high stiffness, high tensile strength, low weight, high chemical resistance, high temperature tolerance and low thermal expansion makes them very popular in aerospace, civil engineering, military and motor sports along with other competition sports. However, they are relatively expensive when compared to similar fibers such as glass fibers or plastic fibers. Carbon fibers are frequently based on oxidized and via pyrolysis carbonized polymers like PEN. However, the end creation is nearly pure carbon. Fiberglass. Fiberglass is a type of fiber reinforced plastic where the reinforcement fiber is specifically glass fiber. The glass fiber may be randomly arranged but is commonly woven into a mat. The plastic matrix may be thermosetting plastic, most often epoxy, polyester, resin or vinyl ester or a thermoplastic. The glass fibers are made of various types of glass depending upon the fiberglass used. These glasses all contain silica or silicate with varying amounts of oxides of calcium, magnesium and sometimes boron. To be used in fiberglass, glass fibers are made with very low levels of defects. Fiberglass is a strong lightweight material and is used for many products. Although it is not strong and stiff as composites based on carbon fiber, it is less brittle and its raw material are much cheaper. Its bulk, strength and weight are also better than many metals and it can be more readily molded into complex shapes. Application of fiberglass include aircraft, boats, automobiles, bath tubes and enclosures. Polymer fiber. These fibers are the subsection of man-made fibers that are centered on synthetic chemicals. A lot from petrochemical sources, somewhat arising from natural materials by a purely physical process. These fibers are made from polyamide nylon, PET or PBT polyester, phenol, formaldehyde PF, polyvinyl chloride fiber PVC, vinylon, polyolefins PP or PE olefin fiber. Synthetic fibers. Rayon is manufactured regenerated cellulose fiber. It is made from purified cellulose, primarily from wood pulp, which is chemically converted into a soluble compound. It is then dissolved and forced through a spin thread to produce filament, which are chemically solidified, resulting in synthetic fibers of nearly pure cellulose. Because rayon is manufactured from naturally occurring polymers, it is considered as a semi-synthetic fiber. Specific types of rayon include viscous, modal and lyocell, each of which differs in manufacturing process and properties of the finished product. Acetate, it is created from wood. In these fibers, grooves are present that runs parallel to the length of the fibers that can be viewed under a microscope. Also, these fibers are soft that easily melts under hot iron and are smooth. Acetate fibers do not absorb water. The fabric is cool. Next is nylon. Nylon is derived from coal. Nylon was first truly synthetic fiber to be commercialized in 1939. Nylon was developed in 1930s by scientists at DuPont headed by an American chemist, Wallace Carruthers. It is a polyamide fiber derived from the diamine and a dicarboxylic acid. because a variety of diamides and dicarboxylic acid can be produced. There are a very large number of polyamide materials available to produce nylon fibers. The two most common versions are nylon 66, that is polyhexamethylene amide, and nylon 6, that is polycaprolactam, a cyclic nylon intermediate. Raw materials for these are variable and sources used commercially are benzene from coke production or oil refining, furfuryl from oats hulls or corn cobs, or 1,4-butadiene from oil refining. The fibers under the microscope are smooth and clear rods. Nylon is a shiny, tough, stretchable and melts under a hot iron. The fibers is non-absorbent, quick to dry and doesn't wrinkle. The fabric is cool but clammy. Acrylic. Acrylic fibers are obtained from petroleum. These fibers are dog bone shaped with actual cut ends that can be viewed under microscope. The fabric made from these fibers is light in weight, warm and quick to dry. Polyester. Polyester is derived from petroleum. Under the microscope, the rod-shaped fiber looks like nylon, but it is not clear. The fiber does not wrinkle, is silk-like, strong and absorbent. Spandex. Spandex fiber has the exceptional distinguished feature of looking like groups of fibers glued together. Nevertheless, diverse variants of spandex displays different features too. The lycra fiber appears like fused multifilaments across the cross-sectional. Specific fibers are spotted are in shape of like that dogged bone. If viewed longitudinally, they appear to be straight. Glass. The glass fibers look smooth, round, translucent, shiny and flexible. Glass fibers has roughly comparable mechanical properties to other fiber such as polymers and carbon fiber. Although not as strong or as rigid as carbon fiber, it is much cheaper and significantly less brittle when used in composites. Glass fibers are therefore used as reinforcing agent for many polymer products to form a very strong and relatively lightweight fiber reinforced polymer composite material called glass reinforced plastic, also popularly known as fiberglass. This structural material product contains light air, is more dense than glass wool and is especially good thermal insulator. The comparison of synthetic fiber and natural fiber. Natural fiber, it is found from natural source, whereas synthetic fiber is made by man. Natural fiber, in most of the cases, it becomes ash after burning, but synthetic fiber, it melts when burnt. The natural fiber after burning, the smell of the fiber found is the same as the hair burn or paper burn, whereas in synthetic fiber after burning, chemical smell is found. In natural fiber, these are good absorbent and so are able to absorb the heat, temperature, cold, sweat, etc. depending upon condition and nature of fiber, whereas synthetic fibers do not have such property as they are made up of chemical and so do not act as good absorbent. Natural fiber is naturally lengthy. It is not possible to change the structure, whereas length in case of synthetic fiber controlled by man, and the fibers can easily be changed to different structure. The natural fibers has the dust and impurities present on it, whereas there is no dust or impurities could be seen in synthetic fiber. No spinning process is needed for filament production in natural fiber, whereas melt, wet or dry spinning process is required for filament production in synthetic fiber. It grows with its natural color and contains natural crimp in natural fiber, whereas color or added crimp is applied on the filament after passing spintrate in synthetic fiber. The natural fibers are hydrophobic in nature, whereas synthetic fibers are hydrophobic in nature. Fiber needs bleaching process. Synthetic fiber do not need bleaching process. Natural fiber is environmental friendly. Synthetic fiber is not environmental friendly. They are harmful for the environment like polypropylene. Natural fiber are less durable. Synthetic fiber are more durable. Natural fiber has limited use, whereas synthetic fiber use is varied. Microscopic comparison. Microscoping having magnification of at least 100 power can be successfully employed for testing and identifying the fiber contents of a fabric. Microscopic test is very effective for testing the natural fabrics. Difficulties can be faced while testing the synthetic fibers, as many of them have similar appearance. However, one must know what the fiber look like under a microscope, as many finishing processes like macronizing and delustering changes the appearance of the fibers under microscope. Apart from it, dark colored fabrics also cannot be tested with microscope, as light cannot pass through dark substance. For those fabrics, either one of the cloth dyes has to be removed by stripping, bleaching, etc., or they have to be chemically tested. Now let us recapitulate that we have studied in this module. Fibers are materials that will continuously discrete elongated pieces similar to the pieces of thread. Fibers as trace evidence are important in cases that involving personal contact, such as physical attack or murders. Fibers can be classified by two groups: natural fiber and manufactured fiber. Natural fibers are derived from animal and plant sources. Comparison and identification of these fibers are done with the help of microscope for analysis of color and morphological features. Cotton is natural fiber that is most common. Synthetic fibers are derived from natural or synthetic polymers. Regenerated fibers are produced from regenerated cellulose. Example include rayon and acetate. Most man-made fibers are from synthetic chemicals are named as synthetic fibers. Example include polyester and nylon.